In this lecture, I will discuss magnetism with you. Okay. So, we have discussed the electric field, current, everything. So, now the magnetism. Okay. For discussing magnetism, before we start magnetism, there is an electric field. You all know if it is a positive charge plate, it is a negative charge plate, the electric field will always be in positive to negative direction. Okay, if this is a positive charge particle here and it will attract towards negative plate, so it is experiencing electric force Fe in this direction, right? Because this positive will attract towards the negative plate. So electric field will always be in positive to negative direction. But if the charge is stationary, okay, it's not moving, the charge is stationary, so it will experience a electric force in positive to negative direction. Now consider the second case. The second case, this was the first case. Okay. In this case, let us say there is a negative charge, okay, which is coming towards the electric field, which is just moving, and it is experiencing the electric field. Suppose there is no electric field, okay, then what will happen? This charge will move like this, okay, if there is no electric field, okay. But now suppose there is an electric field, that means there is a positive plate, there is a negative plate, a charge is coming and it is experiencing the electric field. What will happen? This negative will go towards the positive plate, right? That means it is moving in this direction, velocity is in this direction, and it will reflect towards the positive plate. So if charge is moving, then this will be the case, and if charge is stationary, then this will be the case. So what will be the direction of electric force? It will be upwards, right? Because the charge is moving towards the positive plate. So this was all about the electric field. Now because we are talking about magnetism, okay, magnetism means magnetic field, okay. So this is my magnetic field. So if we speak about magnetic field, that means there will be two poles, the north pole, this is N is the north pole, and this is S is the south pole, okay, north and the south pole. Now again we will discuss two cases. This is my first case and this is the second case. Okay. Now in the first case, what will happen? The charge is stationary plus. Okay. Charge is stationary. What will happen? Again, it will just go in this direction. And what will happen? Electric field means this charge will have its own electric field, okay, and it is now magnetic field. So basically this electric field and this magnetic field don't have any interconnection, okay. That means the charge has its own electric field and it is in the magnetic field, so they will not be related to each other, okay. But in this case the charge is stationary, okay, it's not moving. Now when suppose it is a positive charge here, right, and it is moving towards this direction like this, okay, it is moving in this direction. Now what will happen? Okay, here velocity is 0 because it's at static position, it's at rest, so initial velocity is 0, but it has some velocity now, okay. Now what will happen? This is very important thing. So I'm writing here, when a moving charge is entered in a magnetic field, it will deflect and will experience magnetic field. Okay, so what will happen? I'll explain you now. So this charge, if the charge is moving, okay, so this charge has its own electric field, okay, and then it is placed in a magnetic field, own electric field and own magnetic field. Okay, when a charge is moving, it has its own electric field and own magnetic field, and now this magnetic field will experience the external magnetic field. Okay, what is the external magnetic field? This north and south plate, this north and south plate, like this is north and this is south. These are the external magnetic field. Okay, so what will happen? This magnetic field the charge is having will interact with the external magnetic field. Okay, so I can write in points. Charge at rest position produces only electric field. Okay, so when the charge is at rest position, it will produce only electric field, no magnetic field. But when it is moving, it will produce the electric and magnetic field both. So charge in motion produces both electric and magnetic field. Okay, so charge at rest only electric, charge in motion produce both electric and magnetic field. So what will happen when a charge Q, let us say charge Q, moves with a velocity v, right, in a uniform magnetic field. So when I am talking about magnetic field, it will be denoted by B. Okay, it experiences a force which is called a magnetic force, and is given by F equals to Q V cross B. Okay, it is very important. You will use this relationship in the numericals. So I explained you, when a charge is moving, it will have its own electric field and own magnetic field. Okay, and it is given by QV into B. And look, what is the heading? Force on a moving charge in a uniform electric field. That means I need to find the force, what I have find out now, on a moving charge in a uniform electric field. So it's not a stationary charge, it's on a moving charge. Okay, in a uniform magnetic field, if the field is uniform. So when it is written Fe, that means I am talking about electric force. When it is written Fg, that means I am talking about gravitational force. And when it is written Fb, that means I am talking about magnetic force. Okay, and you all know the scalar product and the cross product. So if I am talking about the scalar product, that means it is represented by a dot, and if I am talking about the cross product, it is represented by cross. Okay, so scalar product means A dot B equals to AB cos theta, and cross product means A cross B equals to AB sine theta, right? So now tell me, what will happen to this formula? What I can write? Can I write it FB because it's a magnetic force, Q, and now in this formula you can see V cross B. That means it is a cross product. So can I write QVB sine theta, right? Because it is a cross product, right? Where what is theta? Theta is the angle between velocity V and magnetic field B. Okay, this is my theta. And from this formula, can I say that force is directly proportional to Q, force is directly proportional to V, and force is directly proportional to B, right? So everything is depends on theta, right? So if theta equals to 90 degree, that means it will be sine theta will be sine 90 and which will be equal to 1. That means it will be maximum. If theta equals to 0 degree, that means sine theta will be equals to sine 0 degree, that means 0, and that means I can say it is minimum. So can I say that this force can be maximum or this force can be minimum, right? FB can be maximum if theta equals to 90 degree and minimum if theta equals to 0 degree. Can I say that? Okay. Now I will show you when is the force is maximum. Maximum force. Okay. Now let us suppose this is a magnetic field. Okay. So I am showing magnetic field with B. If it's electric field, then I would have showed with E. Okay. And there is a charge, positive charge, which is moving in this direction, right? Let us say the velocity V. Now, can you tell me what is the theta? Now, you see, theta is the angle between velocity and the magnetic field. So, look here. Magnetic field is in this direction and velocity is in this direction. Okay. What angle it is making? 90 degree. This is B and this is V. So, they are making 90 degree angle. That means I can say that if charge moves perpendicular, this is the perpendicular sign, right? If charge moves perpendicular across the magnetic field, that means force will be maximum. Do you understand this point? If it is perpendicular, that means the angle they are making is 90 degree and sine 90 equals to 1. So what will be your force? F equals to QVB sine theta. That means F equals to QVB sine 90 degree because it is perpendicular. Then force will be QVB because sine 90 equals to 1. So that is your maximum force, QVB. So if in question it is asked that what is the maximum force, it is clear sine 90 will be equal to 1. Force maximum will be QVB. Now consider the another case. Suppose this is a magnetic field. Okay, sorry. Okay, let me Okay, now we will consider the magnetic field in this direction. Okay, these lines are straight. Okay, so let us say this is the magnetic field in this direction, and there is a charge, a negative charge, which is moving in this direction. Okay, can you tell me now what is it? Is it the perpendicular or the parallel? Okay, you can see the field in this direction and velocity in this direction, B and V. Okay, so what angle they are making? They are making 90-degree angle. That means again it is perpendicular, and the force will be maximum. Okay, so we have discussed two cases, case number 2, and this is the case number 1, when when the force is maximum. Now we will discuss the minimum force. Okay, when the force is minimum. So let us consider an example. I'm just making the magnetic field. Okay, suppose the magnetic field is in this direction. Okay, this is the magnetic field B, and now in this there is a positive charge. There is a positive charge which is going in this direction, velocity V. Right, this is the magnetic field, this is V. Now tell me what will happen. So we can clearly see magnetic field is in this direction, charge is moving in this direction. That means they are parallel to each other. And what is theta? Is the 0 degree. So what will be the force? Force equals to QVB sine theta. That means force equals to QVB sine 0 degree, and sine 0 degree is 0. So, sorry. Yeah, sine 0 degree is 0. So what will be the force? It is 0. So it will not experience any force, and the force will be minimum. Okay. And we can consider the another case also. Let us just copy this. Suppose this is the case, and in this case, okay, in this case, we are assuming there is a positive charge which is moving in this direction. Okay, in this case, what will happen? So B magnetic field is in this direction, and charge is going in this direction. Okay, V is in this direction. So they are making 180-degree angle, and sine 180 degree is also 0. So F minimum equals to QVB sine 180 degree. That means F minimum will be equals to 0. So always remember, if the charge moves parallel or anti-parallel along the field, the force will be minimum or 0. Okay, so these were the basically how to calculate F equals to QVB sine theta. Okay, and remember, it is a vector quantity and it's a cross product, and we need to find out the force on a moving charge in a uniform electric field. So we have find out this thing. Now the thing is, force is a vector quantity, right? I have explained force is a vector quantity. Okay, vector quantity means definitely it will have a magnitude and it will have a direction. So now, earlier, just now, we have spoken about the magnitude, right? Magnitude means we use the formula and we will calculate the force, like whatever force, 14 Newton, 15 Newton, whatever force will be there, we will talk about the magnitude. But I have not spoken anything about the direction of force. How to calculate, how to know the direction is upwards, downwards, inwards, outwards, what will be the direction of the force, okay? So now the next topic is direction of force. So magnitude we have discussed. Now we will discuss about the direction of force. Okay. So for direction of force, I am writing a statement. The direction of force on a moving charge in a uniform magnetic field is determined by using right hand rule. So it is very important how to determine the direction of force. We will use the right hand rule. Right hand rule means we are using the right hand in finding the direction. So remember, if a charge is positive, that means we will use our right hand. If the charge is negative, that means we will use our left hand. Okay, positive and negative, right hand and left hand. Okay, so I will discuss some examples. Example number first. Suppose it is a magnetic field. Okay, see, these are very, very important. You will get such type of questions in exams. Okay, this is a magnetic field, and there is a positive charge. There is a positive charge which is going in this direction. Let us say it is V. Okay, this is a magnetic field, positive charge going in this direction. Okay, this is the first case. Now the second case. I will make the figures first, then I will explain. Okay, in this, suppose this is a positive charge and it is going in this direction, downwards. Okay, and this is a magnetic field, B. And now there is a third case. So this is a magnetic field. In this case, this is a magnetic field and there is a negative charge now and it is moving in this direction, V. This is a third case. Okay. Now first we will discuss these three cases. Before discussing these three cases, there are three statements. You need to remember these three statements. I am writing here. What is right hand rule says. Okay. So if we see our hands, we have 4 fingers, 1 thumb and there is a palm. Okay. 4 fingers, 1 thumb and there is a palm. So basically I cannot show you my hands right now, but just visualize everything. Okay, it's very, very important. So stretched fingers along the direction of field. Okay. Second, thumb along the direction of velocity. And third, direction of palm gives you the direction of magnetic force. Okay, that means whatever the figure is given to you, you need to put your hands like this, and then you will find the direction of palm. I will explain you now, but I will suggest you to go watch some YouTube video, just a small YouTube video for showing how to determine the direction of force using the right hand rule. Please type this, how to determine the direction of force using the right hand rule. Why I am asking you to watch any video? Because I will explain this thing in the class also. But if some students don't attend the class and they are still not clear about it, just watch a small YouTube video that will help you to visualize how to put your hands. Okay. Now in this case, the first case, I see the first statement is stretched fingers along the direction of field and thumb along the direction of velocity. Okay. So field is in this direction. Okay. So I'm just making the fingers of the hand like this. This is the finger. This is the sorry. Okay. So these are my fingers here. 1, 2, 3, 4. These are my fingers here, right? Okay. 1, 2, 3, 4. These are my fingers. So fingers will be in the direction of magnetic field, and thumb will be in the direction of velocity, like this. So if I place my hand like this, okay, this is velocity, this is my magnetic field. So where my palm is coming, just please place your right hand like this, in which fingers will be in downwards, and thumb will be in right direction. So where will be your palm? Your palm will be inside. Your palm will not face upwards. Your palm will face inwards. So palm will face inwards. Okay. If the palm is facing inwards, that means the force is into the plane. So force is into the plane. Okay. Just visualize it. Place your hands like this. You will see the palm will always go inward. So that means the force is into the plane. You can see the third point. Direction of palm gives you the direction of magnetic force. Okay. Now the second case. So the second case is magnetic field is in this direction. That means my fingers are here. So this is the magnetic field. Okay. And thumb will be in velocity direction. This is my velocity. Now place your right hand in this way, what I have mentioned here, like this. So if you will place your right hand, like means your fingers on the right hand side and thumb on like here, like I mentioned here. So where will be your palm facing? So palm facing will be upwards. So palm will face upwards. Please do it while watching the video. You will see palm will face upwards. That means force will be out of the plane. Is that clear to you? So force will be out of the plane in this direction. Force is into the plane in this direction. Okay. Now the third case. You can just see the fingers. Okay, now this is the important point. What is the important point? This is a negative charge. Negative charge. And what I have mentioned, if it is a negative charge, we will use our left hand. So whatever picture I am drawing now, you need to use your left hand. So place your fingers of your left hand here. Please don't laugh on my fingers here, what I have drawn. And thumb in this direction. Okay. Now place your left hand. This is your B and this is your V. This is my left hand here. I am just placing. So can you tell me now the palm is facing upwards or inwards? So palm will face inverse. So if palm will face inverse, that means force is into the plane. Okay, force is into the plane. So I hope these three examples are clear to you. Now we will do three more examples. Example number 4. So in example number 4, I will draw some dots. Okay, so I'm not playing any game with you. I'm just drawing some dots here. Okay, example number 5, I will draw some cross. Okay, and example number 6, again I've drawn some dots for you. So I'm just copying this. Okay, now we will do these three cases. So before doing these three cases, I'll just tell you an example. Have you ever seen the bow and arrow, right? So this is the head of the arrow and this is the tail of the arrow. If you will see, and suppose you see the arrow is coming towards you, okay? That means you will see a dot. Basically, you will see a dot, okay? If it is coming towards you, that means you'll just see the dot. But if it's going towards outwards, then you will see the cross here, okay? When you see the arrow, just visualize any arrow, okay? So now, if it is showing dot, that means out of the plane, okay? If it is showing dot. If it is showing cross, that means into the plane. You just need to remember this. Okay, out of the plane means there, basically there is an arrow here and we can see the dot because it's coming towards us. So out of the plane, if it is a dot, okay, and if it is a cross, that means into the plane. Okay, so it's very simple now. There is a positive charge, it's going in this direction, so we need to calculate the force. So that means B is given to you. B is now out of the plane. So how you will face the fingers now? Just imagine the fingers, how you are going to place. Out of the plane means like this. So I cannot show you on this paper. I can only show you when you visualize it. But B is outwards. That means B is going outwards and thumb will go in this direction. B will be outwards. Then where will be force? Where will be your force? So force will go in downwards direction. Okay. So this is the direction when the field is out of the plane. Now it is a cross. Cross means the field is into the plane. The magnetic field is into the plane. So in this case, let's assume an example. Negative charge is going in this direction. So when it is negative, that means we need to use the left hand. So please place your left hand into the plane. That means B just into the plane and V in the direction like this. So I cannot show you the fingers, but just your thumb will be upwards and your fingers will be down like this. So your palm will face like here. So your palm will face like in this direction. So that will be your force direction. So if you will place your left hand B into the plane, so basically this will be like, if it is a palm, this is your thumb and this is your fingers. So this will be case like this. Okay, and in the first example also, if I explain B outwards and V, B outwards and V here. So your, so basically this, your finger, your thumb, so your palm will face like this outwards. I cannot draw this, you need to visualize yourself. Okay, now in this case, let us assume this is a positive charge, it is going in this direction. Okay, this is velocity. Now it is dot, that means B is out of the plane. Okay, B is out of the plane, B is going out of the plane. So how you are using the right hand, obviously, because it's a positive. So imagine B is out of the plane, and then B is out of the plane and finger is here. So where will be the force? So force will be in the left direction. Please visualize it and then you will find it. So this all about the 6 examples of showing the magnetic field and the charge. Please visualize it properly, and if you are not able to and have not attended the class, that means you must watch a very short video of how to visualize the force. Okay, you will find it. Thank you so much.